The heat dissipation of the LED headlight determines the lifespan of the three aspects of heat dissipation. 1. The matching of electronic solutions. 2. The structure of heat conduction and heat dissipation. 3. New materials for heat conduction and heat dissipation. The structure of heat conduction and heat dissipation is divided into two aspects. 1. With fan for heat dissipation. 2. Without fan and with coil heat dissipation. The heat generated by the lamp is poured down to the radiator, and the heat is dissipated into the air by the fan. Like the kind of copper lamp, although fan let the heat automatically exchange heat with the air to dissipate heat. The disadvantage is that the power cannot be high, and the maximum is about 80 watts to 22 watts. The structure of active heat dissipation includes the chip size of the lamp build. Heat packaging molded. This single CSP did not do thermal pad separation and has been eliminated. The three chips together make high power packaged on a ceramic board. Firstly, the chip generates heat, which is then transferred to the ceramic board. The size of the ceramic plate is her first carrier for heat generation because the chip is packaged on this ceramic board. Ceramic machine plate is divided into aluminum. The two chips are the same size. The larger the ceramic board, the stronger the heat dissipation. Because the larger size, the more contact surfaces, the faster the heat dissipation. So 1860 lamp views, the light emitting surface is the size of the chip. The heat transfer size is the size. Of the ceramic substrate size 1860 refers to the size of the ceramic base plate. Possible, it is best to use 3570 lamp. If the first carrier is a ceramic machine board, and the second carrier of a lamp is a patches, which are attached to the coil plate. Therefore, the second carrier is our copper plate. First of all, the larger the ceramic substrate and the copper plate, the better the heat dissipation. The third carrier is our aluminum parts. The heat generated by the lamp is transferred to the ceramic substrate and then to the copper plate. The copper plate is then passed to the aluminum parts. The aluminum part then transfers the heat to the end of this aluminum part and blow it way through the fan here. And the exchange here to dissipate heat. That is how it dissipates heat. Now, let's talk about the structure of this aluminum part. Aluminum parts are divided into single-sided and double-sided. This is a CNG panel. This is called a single panel, which means that only one side of the lamp is attached, and the back is a coil plate without a circuit. Double-sided means that there are lines on both sides of the front and back, and there will be lamp beads on both sides. The center of the single panel is 5 mm, and the copper plate is relatively long. And reach this location, his heat transfer is conducted through the two poles to the coil plate. This aluminum piece conducts down to the heat sink, followed by two copper plates. This is a single panel structure, and it is a split type. This is a one piece. This is a split. This is the radiator, divided into two parts. Some are twisted in, some are inlet extruded. Profiles are actually so thick. Finally, it is processed into such a light pole. It weighs raw material. In order to save cost, some factories separate the light pole and radiator. This is called a split type, and the heat dissipation is not good. The heat goes down from here. The single panel is like this, and the heat transfer is not as fast as the overall structure. The temperature of the split body is at least 10 degrees Celsius higher than that of the one body. Obviously, the heat dissipation is not good. This is a single panel for the structure of aluminum parts. The single panel is divided into all-in-one and the part. The part can save costs. This is a double panel. The light center of the single panel is 5 mm. The middle of the double panel is 3 mm 1 mm copper plate, plus or 8 mm copper plate, is the light center of 5 mm, so it does not focus light. In order to focus the light, this kind of shape appears. The middle is 0.9 mm. To be UT if it is so thin, the heat conduction is not good. And also add 2 copper plates of 1 mm, that is, to achieve 2.9 mm light center. Finally, this kind of doubly-sided product appeared, a copper plate with a thickness of 1 mm, with the lamp piece on both sides, and the luminous spacing between the two lamp pieces is 1 mm. This structure is called aluminum sandwich coil. On this is 2 pieces of copper clip, aluminum. This is an aluminum and copper structure. The optimal structure is the 2-half structure. This is the slot for the light board. Put the plate on top like this ST structure. But this side will make a plus upgrade to a 2-half structure. It is between the 2 copper sheets, aluminum and aluminum, and plus copper. This is another 2-half structure, which is currently the best thermally conductive structure. This structure will continue to be upgraded. The third load is aluminum parts. The heat dissipate on area of the aluminum sheet is the surface area of the fin, because the heat will end up in this radiator. The greater the surface area and the air contact, the faster the heat dissipation. The steel clip as the fan inside the back cover and the fan form a hole, and the heat dissipation effect is the best. The lamp piece generate heat, which is transmitted to the ceramic substrate and the lamp board, and the lamp board is transmitted to the aluminum parts, which is the heat dissipation process. You can look at the structure of the lamp and judge the service life of the lamp according to the entire heat dissipation process. First of all, see if he is a 2.5 structure. Here see how big the heat dissipation surface of the fins is. How much surface area to dissipate is the design of the back cover of the fan ventilated, and how much wind power is generated. A good heat dissipation can ensure its long service life.